let's take a look at what happens when we have horizontal shifts. So I'm going to go through the same sort of idea as what we talked about with vertical shifts, is always look at what is happening to the parent graph itself. So the parent graph for us was defined as f of x, according to this definition. And we could kind of see how it's been modified. It looks like there is a constant added or subtracted to or from the variable inside the parent graph. And that variable inside the parent graph happens to be an x. So if we kind of go towards the same sort of reasoning with our movement, remember that x movements, when you have an xy coordinate, tells you to move left or right. So if you have something being modified, if you have something like x plus 2, well, that's telling you that the x numbers are going to be moving over 2 units. But there is a slight catch with horizontal shift. It is not exactly how you think it's going to happen. So if you had some experience with this, just bear with me for a little while I try to make my analogy. Vertical shifts are nice. They go exactly how you think. Positive moves upwards, negative moves downwards. But horizontal shifts are actually the opposite of what you see. So if you can look at this a little bit more clearly, we see a plus C happening at this top one, but it's saying, hey, it's moving left. And that's kind of a little counterintuitive to what we think. And similarly, we have a minus C, but now it's saying right. Well, it's a little opposite. Well, to describe this opposite, just kind of think about your f of x, your function, as a performer who's on stage. And think about yourself as the audience. So it's a little hard to do this because we are not in person, but I'll do my best. This performer on stage, if they jump up, then you see them move upward. If they jump down, you see them move downwards. So their movement is the same as what you see. But when the performer on stage moves to their left, it actually is your right. And the other way around. If the performer on stage moves to their right, it's actually the audience's left. So I don't know if any of you are in drama or anything like that, but they talk about stage left, stage right. That's what we're kind of getting at. So when they're talking about what the function is doing, right here, if I can look at this right here, this is saying that the function is moving to the right, but the way you graph it, because you are the audience, we need to change our frame of thought and say we're actually shifting 2 units left. That's how we're going to see this as the audience. So I know it's kind of a little bit strange. And I would recommend, when you kind of get a little confused on this, just take a look at the calculator. So I believe the last time I used a parent graph of like f of x equals square root of x. Try this one more time. Look at g of x and look at it's the square root of x plus 2. Remember, the number is inside with the x. So there's x movement going on, left and right movement. Now, if you want to play with the TI just for a little bit, let's go and show you. And let's look at our original function is still square root of x, and we have some old function from the last example. But now if I'm going to say square root of x plus 2, see how the plus 2 is on the inside of the radical. We graph it, and we notice, oh yeah, well the blue was the parent graph, and the red was the f of x equals square root of x plus 2. And what direction did the red move? To the left 2 units. So that could be like a nice way to, it's not really cheating, it's really thinking, using a concrete example to describe an abstract example. Very good problem solving technique in mathematics. No one ever tells you about that though. So there you go, that's why you watch the videos. So let me see if I can get this for you. All right, so to describe our particular graph, It's the opposite of what we see. So we say +2, but we're really shifting 2 units to the left. We will just take every single point from our f of x and move it 2 units to the left. So the x values are changing. So that means -4, -1, if we move 2 units to the left, is going to be -6, -1. We'll copy that over to our final draft. -1, -2 is going to be -3, -2. Copy that over, final draft. 2 units to the left from -2, +3 is now going to be 0, 3. Copy that over. And 2 units to the left from 4, 1 is going to be -2, 1. Copy that over, nice little final draft there. So now we can very much see demonstrated that if we connect our points, that the original parent graph has in fact moved 2 units to the left. So final draft, connect your line segments, and you have your transform function. One more together, and then you'll be on your own to kind of try some out. Looking at this next one, we have the f of x graph, and we want to graph g of x equals f of x minus 3. And I want you to kind of pay attention to where that -3 is located, right next to the x. So you're saying that the x values are going to be the ones that are changing. And if x values are changing, there's a left and right movement, a horizontal shift. And it is the opposite of what we see. So this is telling us that we should shift the f of x 3 units to the right. And if you can describe what's happening in English, you have a better time connecting with what's happening with the picture. So I always do that first before I do anything else. So the x values are being modified. As the audience member, you're trying to see which way is the graph moving, and it is the function's left if they were facing you, but it is your right. So we are going to take each point, -4, -1. Move it over 3 units, now becomes -1, 1. -1, -1, excuse me. -1, -2, if we shift it over 3 units to the right, now becomes 2, -2. 2, 3, if we shift it 3 units to the right, becomes 5, 3. Sometimes those numbers are a little small for me. And one more point to go. 4, 1, shift it 3 units to the right. Got to draw our own little tick mark. Just try to be as uniform as possible. That's going to be 7, 1. So now if you connect your line segments, you can in fact see that the g of x is the f of x shifted over 3 units to the right. So notice only the x values have changed, not the y values.